Hello, I'm Jason Moody. I'm the Chief Operating Officer for Time to Act. Diffusion Alloys is a coatings provider, and the coatings of choice for Diffusion Alloys is CVD coating, which is chemical vapor deposition. Now, within that family of coatings, there are three principal coating types that we operate, which is aluminizing, boronizing and chromizing. All of these are different flavors of extending the life of the base material. So the spaces that aluminizing might be used is in the very high temperature plant or industrial equipment sector, where very hot gases of different types, different humidities are used through pipe work. And when exposed to very high humidities and very high temperatures, you get different failure mechanisms. By aluminizing the base material, you can extend the life of the product. Not everybody transitioned towards energy transition applications and finding those new applications. What we're trying to articulate with that statement is that when you were working in gas turbines, a lot of players, and it was a race to the bottom on both price and quality. So those people may not have been competitive by the end, but us pivoting towards the energy transition has afforded us to keep our knowledge, keep our staff, keep all of that infrastructure, and just apply it in a new way. So as I think we're all aware, the energy transition is an emerging and evolving landscape. And some of the solutions that we're finding now with applying diffusion coatings to these products are completely unknown. But what we are finding more and more is that people in the hydrogen handling space, the energy storage space, the electrolyzer and solid oxide space, all emerging technology, including nuclear, they're finding some really interesting applications for our coatings. A lot of these things are the very early stage, so they're transitioning, but what we can see is the pipeline ahead of us is phenomenal. That's all. So for parts that we process, they're typically in operation above 600 and 700 degrees centigrade. And at those elevated temperatures, paints and normal coatings, they wouldn't last very long. So what we do, and what the CVD or diffusion coating process really is a core diffusion of two materials. We deposit an aluminium or a chromium-rich surface treatment onto the metal, and the way that's processed, it becomes part of the base material. So it's not like a paint that could peel off, it becomes part of the metal. So if a coating wasn't to be used, you have very limited options. You either go through a more aggressive replacement program where you change the parts out much more frequently, or you use some very expensive, less available super alloys. And that is, for obvious reasons, quite prohibitive. A big part of why diffusion coating isn't as mainstream as perhaps it should be is an education of the engineering community. A lot of people don't really understand what a diffusion coating is, let alone how to apply it. So a big part of what we're going to do is to educate people with thought leadership pieces, and we're going to explain where you could use a CVD coating and all the different flavors thereof. Part of what Time to Act has done, and we haven't articulated it yet, is that we've centralized the sales function to the point where we now manage all the marketing, so we're starting to go out and be more proactive. In the past, it's been very waiting for someone to pick up the phone, and those people often, they already know what a diffusion coating is and they'll tell us what they want. Now we're going to go out to them and tell them what they need. So one of our recent announcements is the separation of DACS and DACT, which is the two principal parts of diffusion alloys. And what the difference is one of them is focused chiefly on flexible capacity, and that might mean capacity where it needs to be instead of just in the factory in our Middlesbrough plant. And what I think we'll be spending a lot of time on in the next 12 months is just building up what that flexible capacity means and how to develop that with our partners. The legacy market, we can estimate what the size is, but the new market where we're educating people of how to use our coatings, we don't know. It's big. So we have a measure that we're calling the bow wave. The bow wave is broken down into all of the different customers that we're speaking to, who have been quoted, who understand exactly what they need, but they're probably in different stages of the final investment decisions with their supply chain. Once their final investment decision comes in, we expect with a good degree of confidence that we would get that work. But because it's not a committed PO, we wouldn't put it in an official pipeline number. So we call it the bow wave. On listing, that number was 17 million, and it's always under review. Some of the partners that we're working with, they're in incredibly large industrial processes that are often state funded. And some of those projects, that can take months to years to come through the whole pipeline. So instead of putting them into an official order backlog, we keep them in the bow wave so we can understand exactly what the opportunity size is for the time when it comes towards us. So an example of one of the projects that might be in our bow wave could be a large hydrogen plant, and that comprises of a whole host of different coating technologies and coating services. The way that would transition through the process is we would stay very close to our customer. We would develop the relationship to the point where we understand that if they are successful in the final investment decision and they're up their full supply chain, then we would be successful in securing that work. There are customers in our bow wave analysis that are at every stage of that cycle, some very early discussions and some very much about to break, but we're in discussions with all of these customers at all times. Thank you for watching. I hope you enjoyed the video. Please be sure to submit any questions and we'll look forward to answering them.